Now that you've finished your Discovering 45, 45, 90 Triangles lab, you should already kind of know how this is going to work out. But just so you can see where the formula comes from that you figured out, we're taking a look at a square. The one thing we know about as a square is that all the sides are equal. So notice the hash marks. And that every angle is 90 degrees. So now if I wanted to turn this into a right triangle, obviously I could draw a line called the diagonal down the middle. So once I've drawn that diagonal, I've now taken these 90-degree angles and split them into two. So this would be a 45-degree angle. This would be a 45-degree angle, and then this one, of course, would still be 90. So now if I isolated this, and I called this side x and this side x, and I wanted to figure out what's the length of the hypotenuse, I could actually set up an equation. So across from the 90, this is always our c. So if we were to set up our a squared plus b squared equals c squared, I would have x squared plus x squared equals c squared. So then if we were to combine like terms, x squared plus x squared is 2x squared. So normally now we would divide by 2 and then try to square root, but since we're using just variables, I'm going to go ahead and square root now. So I have the square root of 2 times basically the square root of x squared. So I'm separating these two things. But if I multiplied them back, I would still get this. And then over here, I still have this square root of c squared. Earlier, we learned that the opposite of squaring something is to square root. So over here, the square root and the square would cancel, leaving me with our hypotenuse. Over here, the square root and the square would cancel, so I have x, and then I can't take the square root of 2. So what we figure out is that x root 2 is c. Or you could say that our hypotenuse in this case would be x root 2. So over here now, this is x square root of 2. So down here on this bottom triangle, all we're wanting you to do is to write down your formula. So anytime that you have a 45, 45, 90, what I want you to remember is that the legs are going to be x, and the hypotenuse is always going to be your x root 2. And then you might remind yourself that this is your c, or is always across from the 90-degree angle. So here, this would be our x, the bottom leg would be our x, and then our hypotenuse, which is always across from the 90, is going to be x root 2. So that's the formula, and a lot of the times you will see the formula written as x in ratio to x in ratio to x root 2. Oops, sorry. All right, so now you can actually see what I wrote. So when you're trying to solve for one of these components of a special right triangle, the first thing that I want you to do is put the formula on the triangle. Then the second step is I want you to solve for your x value. And then the third thing is going to be to substitute, or remember that just means plug, your x in. So let's look down here at the bottom at example 1 and see how that works. So if we're looking at example 1, remember step 1 is to put the formula on the triangle. So if we were trying to identify, this is a leg, so this is x. This is a leg, so this is x. But notice there's already something here. And then this would be our x root 2 because it's across from the 90-degree angle. So step 2 is to solve for x. Well, what you're going to do is find a place on the triangle where you have part of your formula and a number that's already there. So notice this side wasn't labeled, this side wasn't labeled. So this is what we're going to use to solve for x. So all I do is put an equal sign in between. And then it's like an equation, except for in this case, I don't have to solve. So in this case, x is equal to 5. So then part 3 is to substitute x back in. So down here we've got AB. Well, AB, oh, I should have changed colors for you, sorry. So AB is equal to x. Well, x is just 5. And then AC is over here, so A to C is equal to x root 2. Well, I've got to plug x in right here. Well, x was 5, so I replace x with a 5. So then AB is 5 units long, and AC is 5 root 2 units long. So on this one it's pretty easy because it matches the pattern. 5, 5, 5 root 2. So that's our 5 in ratio to 5 in ratio to 5 root 2, which lines up exactly with our formula, which was x, x, and x root 2. Good. So flip it over and let's try another one. So on the back, we've got another triangle. Again, what we kind of need to remember are the steps. And on this one, you get to go back to rationalizing the denominator, which was all of your favorite parts. So step 1, put the formula on the triangle. So this is my leg, so this is x. This is my leg, this is x. Across from the 90, this should be my x root 2. So then step 2, we're supposed to solve for x. So remember, to solve for x, we've got to go back to where we find something that was already there with our formula. And all we do is put an equal sign. So now this is what I'm going to use to solve for x. So I've got x root 2 is supposed to equal 4. Well, just like if I had this, 2x equals 4, to solve that, you would divide by 2, and we would get that x is 2. So we're using the same idea, except for instead of dividing by 2, we're dividing by the square root of 2. So this would cancel, and I now have x equals 4 divided by root 2. If we tried to put that in the calculator, it's going to give you a big, ugly decimal. So remember, this is where we have a square root in the denominator, so we have to rationalize, which remember is a big word for multiply. So I'm going to multiply by whatever's in the denominator, so root 2 times root 2. So 4 times root 2, we can't put together, so that's 4 square roots of 2. Then root 2 times root 2 is the square root of 4. So then if I simplify, I've got 4 root 2, and then the square root of 4 is just 2. And now I can divide 4 by 2, and I get 2 root 2. So my final answer is that x equals 2 root 2. Now, what you need to recognize in the very beginning, we started with 4 divided by root 2. If you notice, really all I did was take 4, divide by 2, and I got 2, and then I put the square root back. So it's a little trick if you catch on to it. But if not, these steps will always work. So once I get my x value, remember step 3 is to substitute x back in. So the first thing they asked me for was AB. So if I look at AB on my triangle, AB is just x. Well, x is 2 root 2. And then BC is the same thing. BC is x. So this is 2 root 2. So here I would have 2 root 2 units and 2 root 2 units, which again should fit our formula. We had x, x, and x root 2. So this would have been 2 root 2, 2 root 2, and then that would go to 4. So that's what it would look like in ratio. These two should always be the same, and then this should be your different one. Okay, let's try number 3. So number 3, again, remember your first step is to put the formula on the triangle. So then this is our leg, this is our leg, across from our 90, this should be our x root 2. Then after that, remember our next step is to solve for x. So we need to find the place on our triangle where we've got something together. So here it is. So I've got x root 2 is supposed to equal 3 root 15. Remember, to solve, we're supposed to divide by root 2 so that these cancel, leaving me with just x. But then I can't leave this answer like this, so I have to rationalize the denominator. That means I multiply by whatever's in the denominator. So then 3 times 1 is just 3. And then root 15 times root 2 is root 30. And then on the bottom, root 2 times root 2 is root 4. So now I have 3 root 30 over 4. So now what I would want to do is see if the square root of 30 simplifies. So I have 3 root 30. 30 does break down into 5 and 6. And then this is 5 and 2 and 3. Are there any pairs that go together? No. So 3 root 30 would not simplify, and I would just leave it like this. Oh, sorry, I messed up. The square root of 4 is 2, not 4, sorry. So x, your answer is actually 3 root 30 over 4, over 2. I'll get it right one of these days. And if you put 3 divided by 2 and you got 1.5 root 30, it's not really wrong. This is more correct, but this wouldn't be incorrect. So now we're supposed to go back, and our step 3 is to substitute x back in. So they asked me for AB. Well, if I go up here, AB is x, which we just said was 3 root 30 over 2. Or 1.5 root 30. And then they ask me for BC. Again, it's over here. That is also x. So this would be 3 root 30 over 2. Or 1.5 root 30. So 3 root 30 over 2 units. 3 root 30 over 2 units. Alright, so we've got one more down here at the bottom. Okay. Again, I am going to go ahead and go over it for you just because I want to make sure that you guys know what you're doing. So yes, one more set of notes that I'm actually going to go over every problem. So number 4, again, the first step is to put the formula on the triangle. And again, once you're past the notes, you don't have to write these steps all the time. It's just I'm wanting you to get familiar. So this is our x, this is our x, this is going to be our x root 2, and yes, I did already put the equal sign there. So step 2, solve for x. So I've got x root 2 is going to equal 1/2. So this is where it gets a little bit confusing. I'm supposed to divide by the square root of 2. Well, this side is already divided by 2, and then I'm supposed to divide again. So if I have this, what this really means is that you've got 1/2 times, and then this is over an imaginary 1. So if we have a fraction divided by a fraction, you have to flip this one over. So this one becomes 1 over root 2. So what we really have here, 1 times 1 is 1. And then on the bottom, you actually have 2 root 2. So the idea is the original fraction was already divided by 2, and then we needed to also divide by root 2. So it ended up on the bottom with the 2. So now we're ready to rationalize. So we multiply by root 2 over root 2. So that gives me root 2 over 2 root 4. So that's root 2 over 2 times 2, which means that x equals root 2 over 4. So then the last step is to substitute the x back in. So they again ask for AB, which is equal to x, which we just said was root 2 over 4. And then they also ask me for BC, which is x. So that's also root 2 over 4. So then both of my answers are root 2 over 4. So again, the hardest thing about a 45, 45, 90 is when they give you the hypotenuse. If they give you any of these, so they could give you 1.5, it would be 1.5, 1.5, 1.5 root 2. If they give you 100, for this, it would be 100, 100, 100 root 2. They could give you 3/4, 3/4, 3/4, 3/4 root 2. So if they give you one of the legs, it's very easy. But when they give you the hypotenuse, that's what makes it difficult, which is why most of the problems we did dealt with the hypotenuse.